Hi, in this lecture we are going to be talking about random forest, another very useful method, machine learning classification algorithm. So random forest is one of the most popular and accurate algorithms that are available for machine learning. It is one of the most popular in the sense that when you have these data science competitions, this is one of the algorithms that is very popularly used. It is an ensemble method that is used to build decision trees. What is an ensemble method? Ensemble method is somewhere that you don't make one decision, you make n number of decisions and then take a vote. So let me explain a little more. Suppose that I want to buy a laptop and I want to get some opinion about whether I should buy a laptop or not. If I just go and ask one friend, should I buy this laptop or not? And he gives me an answer yes or no. That is some kind of basic decision making. So every friend becomes a model and I use just one model to get an opinion and I only get one answer, which is yes or no. Rather, if I go and ask 10 of my friends whether I should buy a laptop or not, and then I get 10 different opinions and then take a vote between this one. Okay, 7 of these people said yes, 3 of these people said no. So yes is higher than no, so I should go and buy this laptop. So that is called ensemble decision making. You are using multiple people, multiple brains. So in this case, what happens is that random forest is an ensemble method built on decision trees. So every friend here is a decision tree and random forest is nothing but a collection of trees. So that is why it's called a forest, because it is a collection of trees. So in random forest, what you do is you build multiple models, you build multiple decision trees. You use the same decision tree algorithm, but you build multiple decision trees. You will see how we build this multiple decision trees later. And for predictions, what you do is you actually use each of those models. Suppose I build 500 decision trees, I get 500 models. I use all the 500 models to make a decision. So I will get 500 different results. So I'm trying to figure out if a patient is actually sick or not. I will get 500 answers, yes and no. Then I take a vote. I get how many yeses I get, how many no's I get, and whichever is the highest, I'm going to choose from that. So you take a vote on these results to find your best answer. That is why it is called an ensemble method. You actually, in an ensemble method, when machine learning, when you say something is an ensemble method, you typically have multiple models. And every time you try to make a decision, you apply all these models and then take a vote between those multiple models. So how this one works is, let us say you have a data set that contains m samples or m rows and n predictors and n columns. There are n columns and m rows in that sample. You build x trees, but each tree is built with a different subset of data. And that is how there is a possibility of each tree being different. If you use the same data for building each of the trees, all trees will look alike. But for each tree, you pass a different subset of data. Out of these m samples and n predictors, you pass a different subset of data to each of the tree. So how is this subsets chosen? They are chosen randomly. So you choose m out of these m rows and n columns, you choose a subset of rows and a subset of columns randomly. And that is why this algorithm is called random forest. Random because you use the random mechanism to select the rows and columns. Forest because you have multiple trees there. That is why it's called random forest. For example, if you have a data set that has 1,000 rows and 5 columns, each tree is built using 700 rows and 3 columns. So you choose randomly 700 rows and 3 columns and then use that data subset to build a tree. Now you don't have to worry about writing code for choosing these rows and columns, because random forest algorithm implementations or libraries will do them for you. This is more for your understanding. Sometimes you can control in terms of what percentage of rows you want to choose and what percentage of columns you want to choose for every sub tree you're trying to build. But mostly they optimize themselves in terms of that selection process. So the data subset is used to build the tree. And for prediction, the new data is passed to each of these x trees and you get x possible results. And then you take a vote among these x possible results to see which one I want to buy. So for example, if you're predicting yes or no, and then whether somebody is going to buy a product or not, and you build 500 trees, you will get like 350 Ys and 150 no's, and then you know that 350 is greater than 150, so I'm going with the decision of yes. So this is like a voting decision, a more democratic kind of decision making process that you apply. So the most found result is the overall prediction that is you're going to be doing. So random forest is about building multiple trees, each with a subset of data chosen randomly, and then whenever you have to predict, you basically run through a voting mechanism to make a decision, and that is your ultimate prediction. So the summary for random forest, let's look at what are the advantages. One of the advantages is that is very highly accurate. Every tree is being built with a different subset of data. What that means is a lot of the noise that is there in the data gets eliminated. Only the proper possible signals keeps getting built into these models. So it is found to be very highly accurate, and it is efficient with a large number of predictors. It doesn't matter if you have like 40 or 50 predictors, given that each tree chooses a subset of predictors. The number of predictors you choose for a given tree is typically the square root of the number of actual predictors available. So suppose you have 4 predictors, each tree is built with 2, but suppose you have, let's say, 16 predictors. What is square root of 16? Maybe something like 4, right? So you only use 4 predictors for each of the subtrees built. So it is pretty easy and flexible in terms of adjusting itself to a large number of predictors. Another big advantage of random forest is that it is fully parallelizable. Given that each tree is built independently, the tree building process can use like multiple CPUs. They can all run in parallel, build the trees, and then you can collect all the results back. So same applies with when you're doing predictions. You can do predictions in parallel with each of the trees that are being built using multiple CPUs, then collect back the results. So in that way, it is fully parallelizable. You can use some parallel processing techniques to really speed up things with random forest. It is also very good with missing data. The benefits of decision trees, the individual decision trees, also accrue towards random forest. Shortcoming is, of course, it is very time and resource consuming. You have to build 500 trees instead of one, so that is going to take a lot of time. Unless even if you apply parallel processing and stuff like that, it is going to take a lot of time. For categorical variables, bias might still exist if the levels are disproportionate. Now, let us explain what do you mean by the levels are disproportionate. Suppose you are trying to predict yes or no. So there is 2 levels, yes or no, in that particular categorical variable. There are 2 values, yes or no. Those are what we call levels. So in the training data set, if you have like 50 yeses and 50% yes and 50% no, that is equal proportion. Suppose in the training data set, 95% of the values are yes, only 5% of the values are no. That is disproportionate. When you have that kind of a disproportionate data set, where one of the class types dominates the other classes. So in this case, the Y dominates the N so much. Models that you build on that kind of data pretty much will bias towards that particular Y. So anything if you have like 95% yes and 5% no in the training data, the model that you build is always keep predicting yes all the time. The risk there is if the accuracy numbers that will come out with that kind of prediction will be highly accurate, because suppose you have 95% yes and 5% no in the training data, the same proportion will also exist in the testing data. So in the testing data, you take and start predicting everything as yes. You still get 95% accuracy, because you have 100 records. Of them, 95 are going to be yes. You just go and blindly predict all of them to be yes. You will still get 100% accuracy in the test data. The problem there is whenever the no happens, it is not going to be sensitive to that no at all. So these are places where you have to be careful. One of the techniques that is usually applied when the levels are inappropriate is the data set that you use. Choose a data set out of the training data set where the levels are almost equal. When you have 100 records and 95 of them are yes and 5 are no, rather than taking 100 records, only take 20 records with 5 yeses and with 5 no's and 15 yeses. So that way some proportion is achieved. Only issue there again is you have to use really a large set of data so that you don't get any kind of prediction errors. So those are some of the challenges you will face when you have disproportionate levels of values. This is used in scientific research a lot. In scientific research is a place where you're not really worried about speed of prediction or speed of model building, so you can happily go and use it. Competitions, a lot of competitions use random forest. Another place where accuracy is most important, speed of prediction is not. Again, this is used there. It is also used in medical diagnosis to predict if a patient is sick or not sick, that kind of decision making. Again, random forest, highly accurate, very time consuming. That is the summary of random forest. Thank you.